Namaskar and welcome back to another lecture in our course on infrastructure asset management, which is being offered under the MOOCs initiative of the Government of India. Now, today we are starting our discussion on week 8, the last week. The title is Asset Management, Inspection, Evaluation and Action. So, today we will get started with this module and talk about a maintenance framework. Moving on, as always, I will warn you that this material is strictly for academic and instructional purposes and should not be used for any other purpose. What you see on the screen is like the blackboard in the good old days. Please make it a habit to make notes as usual using what is being visually projected and what is being orally stated. Now, so far in this course we have talked of an overview, we have talked of the schematic representation of deterioration and performance with time and examined the concept of service life in that framework. We have talked about some case studies which highlighted the role of different stakeholders in different phases of a project or a structure, and we have talked about the importance of a comprehensive strategy towards infrastructure asset management, which includes social issues, economic issues, environmental issues, resilience issues and so on and so forth. We have talked about a decision making framework including performance modeling considerations in budget allocation. We have also talked about some deterioration mechanisms in the case of concrete structures and the measures that are taken to ensure their durability. This is an illustrative example, and the idea is that once you understand something about concrete structures and how we approach asset management of structures made with concrete, you should be able to develop a similar framework for other structures. We have talked about relating quality control and specifications to the deterioration and initial performance. Now, moving on, the present module will focus on inspection, evaluation and action. The focus being again on concrete structures as an illustrative example to show the principles involved. We will concentrate on the overall strategy for non-destructive testing, evaluation and action, and today's discussion will be on generic principles. This will be followed by an overview of some of the non-destructive testing tools and a brief discussion on the action such as repair and retrofit, and finally, at the end of this module we will have a discussion closing out this course, where we will talk about what we set out to achieve, how we went about achieving it and what we have actually achieved through the 8 modules spread over 8 weeks. So, now moving on, this is a picture which has been adopted from the JSC specifications. Now, we have talked about this kind of a graph where we talked about performance on the y axis and time on the x axis. This being the initial performance and this being the performance predicted at design stage. In case 1, if we monitor the performance over time, the performance predicted at different times or determined at different times shows that we are in the safe zone, that is, no action is required. The action will be required if the performance starts to deteriorate faster than what was anticipated. Another thing which I would like to draw your attention to as far as this graph is concerned is that there is a design service life, that is the service life for which the structure has been designed. Now, given the fact that this design service life could be very long, maybe 100 years, 150 years, whatever it is always possible that somebody else at some later point in time will come up with a different number for the scheduled service life. That is, we say that okay, this structure was designed for 100 years, but maybe we need it for another 100 years or for another 50 years we need to extend its life, or we may say that well, we may not need it for all the 100 years because we are doing something else at the end of 25-30 years, and therefore, we reduce the design service life in that sense to something called a scheduled service life. So, all our predictions and so on based on the performance time graph have to be then re-engineered to meet the requirements of the scheduled service life. So, that is something which you need to watch out. This is in addition to what we had talked about in our earlier discussions. Then we have also talked about repair and retrofit measures. We will see in this discussion today, when we are talking about the general principles of maintenance, that maintenance basically has 2 components. One is the inspection and the second is the action based on the inspection. So, once we decide to repair, then we try to change the level of performance. That is one way of looking at maintenance action. Now, once we do this, whether we do it here, whether we do it here, that is a different story, but once we do it, we enhance the performance level and then we can arrive at a remaining service life. Now, whether we talk of the remaining design service life or we talk of the remaining scheduled service life is a matter of detail which I am not going into. Now, moving on, let us try to understand what is maintenance. Maintenance can be defined as all actions to keep the performance level above the required level during the service life. Now, we can talk in terms of three types of maintenance: preventive, corrective or observational. And before we go to the definition of these terms, I would like to only reiterate what we already stated, that the planned or scheduled service life is the period during which the structure is expected to perform, and the design service period is the time period where the structure is expected to perform at the time of design. So, now at the time of design we can call it the design service life, whereas at any point in time we can always talk in terms of a planned or scheduled service period. So, that is what we have explained before. Now, let us move on and see the definition of the three types of maintenance that we talked about. Reiterating the definition of maintenance, we talked that all actions to keep the performance above the required level during the service period can be called maintenance. This could be preventive, where remedial measures implemented before the deterioration becomes apparent. So, we could have a situation that performance is still here, there is no change in the performance, but still we would like to do some maintenance action. That is what is preventive maintenance, that is we do not want to have any onset of deterioration. So, instead of performance, if we were looking at deterioration, even before the deterioration takes off from here, we carry out maintenance action. So, that is what is preventive maintenance. Corrective maintenance is remedial measures implemented in accordance with the decline in the performance. That is, we see how much is the decline, how much is the deterioration, and then try to take appropriate action. So, that is what can be called corrective maintenance, and then there is a class of maintenance action which is being called observational maintenance in the JSC standard. Now, this is a reference text and different countries and different organizations are free to come up with their own definitions, classifications and so on. Now, coming back to this observational maintenance, here we must keep in mind that remedial measures are not implemented even after deterioration becomes apparent. Now, this is a situation that will happen when the structure is having a very short service life. So, we say that okay, even if it deteriorates, it does not matter, so long as it does not fall below the required performance levels or it does not exceed the acceptable deterioration levels. So, there is no need to do any maintenance action as such, and the other case is that action cannot be implemented. So, there are several situations as far as infrastructure is concerned where once built and going into operation, it is not possible to repair that structure or retrofit that structure. One case in point could be, let us say, foundations below the ground, especially if they are deep foundations and so on, then it is an extremely difficult, very unlikely situation that we will be able to carry out any remedial action. Now, but does that mean that we do not monitor them? Monitor in the sense, we do not try to keep track of what is going on. Even if we cannot repair or retrofit or rehabilitate a particular component, we must still continue to inspect. Now, there could be tools which will give you an idea as to what is going on at that point. Maybe from remote techniques and so on, it is possible to know what is going on, but we are helpless in trying to do anything about it. So, that is what comes under observational maintenance. As far as preventive maintenance and corrective maintenance is concerned, remedial measures are implemented, that is, they can be implemented and they are obviously implemented. In observational maintenance, they cannot be implemented, but still we should continue to do an inspection. So, that is one way of looking at maintenance action. Now, having classified maintenance actions, let us talk about inspection. Inspection is the first part of maintenance action. In principle, inspection could be defined as a generic term for action of investigating the presence or absence of factors that cause anomalies or the degree of these anomalies. So, basically what is being stated here is inspection involves looking for signs of deterioration or the degree of deterioration. So, basically we are looking at whether the structure has deteriorated, it is showing signs of anomalies, or what is the degree of these anomalies. So, that process is inspection, and that inspection can be classified into initial inspection, which is made at the start of the maintenance to determine the initial conditions of the structure. It could be routine maintenance, which is carried out periodically with respect to a frequency, comprising simple investigations including visual inspection. So, now I am leaving it to you to think, and I think we did this in one of our earlier discussions as well, that visual inspection is a very powerful method of inspection. Having said that, there is subjectivity and a lot of limitations, but still the power of visual inspection, at least for routine inspections, should not be underrated. Now, coming to the difference between routine and regular inspections, regular inspection is also a periodic inspection, and it comprises of simple investigations to cover aspects that cannot be covered with routine inspections. So, basically what we are saying is that the difference here will boil down to a menu card, that okay, during a routine inspection what are the kind of things that are done, and during a regular inspection what are the kind of things that are done. So, this difference between routine and regular is more in terms of the methods adopted. It could be possible that an SOP states that routine inspections will be carried out every day. Somebody or some machine will go and inspect a structure or its component every day, whereas regular inspections will be carried out weekly. That is, some kind of additional tests will be carried out at a weekly frequency. Apart from these, we can have extraordinary inspections, which could be immediately after an event to determine the extent of damage. For example, there is an earthquake or a flooding or any such event. After that, we need to immediately carry out an inspection to determine the extent of damage. It may be 0, it may be non-zero, but that is something which we need to determine at the end of the event or immediately after the event, and that is what we are talking of as extraordinary inspection. Then there is something called an emergency inspection. Now, this could be necessitated by an event or results of a regular inspection or an extraordinary inspection to check if the structure has also been damaged. So, it is something like saying that okay, if the earthquake hits a particular region, you carry out an extraordinary inspection around that area, and then you carry out emergency inspections at all other areas which you think are susceptible to a similar event later on. So, then we do not wait for the next regular inspection for that, we immediately carry out those inspections, and that is something called emergency inspections straight away. Now, all this hair splitting between the different types of inspections and the frequency and the kind of menu card and so on and so forth is being done because all inspections require resources, and we will see in a later slide that the kind of structures that we look at are simply very vast, and we need to be adequately prepared when we initiate or carry out an inspection exercise. There could be another terminology to classify inspections. It could be standard inspection, that is a specified package of investigation. Again, here it is a matter of menu card that okay, what are the kind of tests that will be carried out during standard inspections. A detailed inspection would be an investigation to collect detailed information not covered by standard inspection. So, this difference is more or less similar to what we talked about when we talked about routine inspections and regular inspections. So, it is a matter of detail, it is a matter of nomenclature, and I will leave it at that. Moving on, the only term that I would like to emphasize is monitoring. Now, monitoring is identifying conditions through installation of sensors and keeping track of whatever data we are receiving from there. So, that is what is monitoring. So, monitoring could be an exercise based on sensors or otherwise, where more real time and very frequent collection of information relating to the appearance or the extent of anomalies is concerned. Monitoring is carried out in structures or infrastructure which is the lifeline, maybe a gas pipeline, maybe a very important bridge and so on. So, there we go for monitoring apart from routine and regular inspections and so on. So, moving forward, the second part of maintenance action is remedial action. Now, remedial action follows inspection. It may consist of detailed inspection, repair, retrofit, limitation of service and demolition or decommissioning. So, any of this can be the remedial action that follows an inspection. When we talk about detailed inspection, we mean that a routine or a regular inspection yields information such that it warrants a more detailed investigation. So, that more detailed investigation carried out on the basis of a report from a previous inspection is a remedial action of sorts. Similarly, repair retrofit is a structural intervention. Limitation of service is like saying that okay, here is a bridge which was open to public, but due to certain anomalies which have been noticed, there is a speed restriction. There cannot be more than a certain number of people passing through this gate and so on. So, this action is a limitation of service of that infrastructure, and of course, we can have demolition or decommissioning as part of the remedial action as well. Now, let us try to understand basically the difference between repair and retrofit. Now, repair is remedial measures to remove the hazards to third party, improve appearance or durability, and includes restoration of mechanical performance to the level available at the start of service. So, basically repair in a certain sense of the word would be limited to restoration of mechanical properties or mechanical performance to the level available at the start of service. So, going back to the performance time graph, repair would mean not more than this. So, that this was my initial level of performance, and any measure that goes only up to this point, whether it takes it here, whether it takes it here, whether it takes it here, that would be classified as repair. Now, retrofit on the other hand are measures to improve the mechanical performance to a level above that available at the time of service. So, basically what we are saying is that this is repair, but if we take action which will take the level of service to somewhere here, then we are talking about a retrofitting exercise. This understanding is very important when we talk about initiating any remedial action in an infrastructure. You recall that there was a case study that we talked about. We said that there was some facility and the owners asked a contractor to repair the facility. So, what the contractor did was simply paint it and remove whatever was visually unpleasant. What was not carried out was a structural assessment of that facility to find whether any major changes needed to be done. Now, that is where the difference between a repair and a retrofit will become very crucial. So, if we have a contractor for repair work, that contractor may or may not be the best contractor to carry out a retrofit job. There is something that we need to keep in mind as owners as to what is the scope of the work being assigned as part of remedial action. Is it simply repair, which means that we just want to do some aesthetic corrections, or it involves something else, or it actually includes restoration of level of service beyond the performance levels. It includes enhancement of the performance levels structurally. Now, that is something which we really need to be very careful about when we talk about repairs, retrofitting and so on, and identification of appropriate agencies to carry out the job. Now, moving on, let us look at the life cycle view of infrastructure maintenance. We talked about planning, design, construction and maintenance being different phases of life cycle of a infrastructure project. Now, information from one phase has to flow to the next phase and should be revised at the end of the completion of that phase. This is very crucial to get the right kind of information for the maintenance of structures, whether they are made of concrete or any other material. Let us try to understand this with more concrete examples. In the planning stage, we create a structural plan, we create some basic plans. This is the information created. Now, what do we carry forward to the next stage? That is what is stated here, is structural plan documents. Now, based on this, we come to the design phase, and in the design phase we have design drawings, structural calculations and so on, and we create structural plans, documentations and design drawings. Based on this, we carry out the construction activity, and this construction activity should result in as built drawings, construction plans, construction records and so on, and this is what has to be passed on to the next phase, which is the maintenance phase. Now, what this is, the structural plan documents, design drawings, as built drawings, construction plan documents and records, because this becomes the basis for maintenance and should form the maintenance record. When we talk of the life cycle of any infrastructure project or infrastructure, then we are talking about how the documents generated at each stage need to be passed on to the next stage with appropriate comments and so on, so that the professionals in the next stage are better equipped to do their job. So, moving on, this is a flow chart view of the same process. We have this, which could be called the design part, which is all planning and design, then we have construction and we have maintenance. So, there is a flow chart involved in each of these processes. So, we need to have a complete understanding, and this needs to be clear to all stakeholders as well, so that they know as to what the other stakeholders are doing in the different parts. So, moving on once again, this is a picture which we have already covered, and this has been simplified to something like this. We start with an initial inspection, we carry out periodic inspection, which could be routine or regular. That is the kind of definition which we talked about today. It need not be visual if we are talking of routine and regular. We carry out an evaluation based on that, an assessment, and then either go for a detailed inspection or we go back to another periodic inspection. Based on this, we carry out another evaluation and decide whether we want to repair or reinforce and carry out that particular activity and close our discussion. So, that in essence is a simple representation of the maintenance action. We have inspection here as the A and then action here, which is B. So, our discussion as far as this module is concerned will be A first, that is, we will talk about a few methods that are more commonly used to carry out non-destructive tests, and there will be a discussion briefly covering some of the methods for repair and rehabilitation or retrofitting of structures. Now, here is an example of an infrastructure that engineers may be asked to maintain. This could be one bridge with the piers and the girders. This could be another bridge. This is taking off from here, going up, as you can see from the levels of these piers. A close up of this view is shown here and here. So, what we see here is that in order to account for this difference in height between this pier here and this pier here, in this case we have already provided at the time of construction appropriate platforms which would be used during the inspection of this area, because this is a crucial area where the girders are resting on the piers. We may like to carry out a detailed investigation as to what is going on here as far as the supports is concerned. So, in order to facilitate that, we need to make the life of an inspector easier by providing these kind of platforms. Another thing is that number of piers here could be very large. The girder here is not a small one. Similarly, the girder here is not a small girder. Now, what we are seeing in these photographs is a view of an elevated corridor carrying the metro. Now, if we want to carry out an inspection, whether it is visual or not, one thing we have to understand is the scale. Then we have to understand that it requires resources, it requires planning. Because we must remember that in order to carry out any test here or here, a certain amount of preparation which will have to be done. Access is not easy here. It may be easy here up to this height, but beyond this point again access is an issue. So, we need to have planning, we need to have resources, and that is why it is important that maintenance budgets are duly accounted for in any planning process. We have talked about maintenance budgets in earlier modules. Here is an example why it is important to have maintenance budgets in order to carry out even visual inspection, because that too requires manpower, it may require equipment, and it requires collection of data and storage of that data in order that it can be compared with the next visual inspection or any other inspection. So, moving on, we are almost at the end of the lecture today, and as mentioned, we will be talking about some non-destructive testing techniques as far as this module is concerned, and then we will be talking about some typical remedial actions that are taken. So, as far as non-destructive testing is concerned, in the context of concrete structures, they being large structures, they can be classified as general purpose methods or special methods for testing. The former, that is the general methods, are used to get a general understanding of the overall health, and that will bring us to an end of this course on infrastructure asset management in a technical sense. But before we finally close, as mentioned earlier, we will have a brief discussion summarizing all the modules and recapitulating what we set out to do and what we have finally achieved through the 8 weeks. And now with that, these are some of the documents you could read to understand the concept of maintenance actions better. I would like to thank all my teachers, colleagues and students who have helped me understand this subject better, and especially my gratitude to my colleagues in the Japan Society of Civil Engineers for allowing me to use some of the material available in their publications. And on a personal note, I feel happy that I am able to share some of the material which I was part of creating about 30-35 years ago as a member of the JSC Committee on Concrete Structures. And with that, thank you so much, and I look forward to talking to you in another lecture about non-destructive testing methods.